before I start the lecture, we have still 3 minutes, so I'll wait till 12:30 to make sure everyone's here. But before I start the lecture, does any of you have any questions? About the quiz, about the homework assignment, everything's clear? Any question? Okay, so I just want to make sure that we are all on the same page. So I expect you guys to study. I mean, I know that it seems really obvious, right? But you'll be surprised at how many students last semester, they didn't study at all during the semester. And I never want to fail anyone, and I always want everyone to get A or like minimum B in my course. And if you just like follow my instructions and just listen to me, I make sure that happens. And if you're struggling with the course, as I said, as we progress with the course, it becomes like more challenging. But if you want to get an A in this course, I'll make sure that happens. So, and it needs like your cooperation too, right? It doesn't just like magically happens, right? But I instruct you, if you're struggling with the concept, I'll do my best. You have like your SI class leaders, they have several sessions. You have tutoring services available for you, and if you cannot make it to any of those and you cannot make it to my office hours, which is like right before this class, I'll schedule more office hours, or just like any time that is that you are available, I schedule like whether in person or Zoom meetings for you. So I don't want anyone to suffer, in my class. And as I said, if you want to do well, I'll make sure that happens. Even if that means I schedule like 5 Zoom meetings with you every week, I'll do that. So I truly care about all of you, and I want you to get A or B. And most of the time, most students that fail the class or like they don't get good grades, there are students who don't care. So I reach out to them. You didn't do your homework, they don't respond back, or don't say anything, and don't do the homework. If you do the homework, you don't need to respond. But if you didn't do the homework and I remind you, I expect you to do the homework, Or like I'll say, anyone has any questions, and they have questions, but they just let it go, they don't ask, Does that make sense? Any questions? You guys, do you have anything to share with the rest of the class so we all laugh? Everything's good? Okay, now your SI Pass leaders, that's like 12:30, so I'm going to start the lecture. They want to make some announcements for you, and I expect you guys to listen to what they're saying.
Hi all, so Sydney and I have received your quiz, and we know what will be on it, and so we're this week structuring our SI Pass sessions to have material that's going to be on your quiz, and a lot of the problems are going to be very similar. So we encourage you, especially if you're worried about the quiz, to come attend these so you can study for that. Thank you.
Yeah, I'll provide SI Pass leaders with all the course materials. They have access to Canvas. They can see all the questions, for like homework assignments, for the quizzes, for your exams, and you can just take advantage of them and just like go to the sessions, learn the materials. Okay, any questions about anything that we just discussed so far? Good. Okay, today I'm going to, last session I finished chapter 2, but at the end of the session it was just like rush. I was rushing to go through the material, so I'm going to review them because they're really important for the rest of CHEM101. And also I'm going to start chapter 3, which is again kind of like the alphabet of what we're studying in this course. So all really important materials. Can anyone tell me what is a conversion factor? Yes. So if I give you a unit like centimeter, right? So I'm more comfortable with SI units. I measure things in kilogram, like meter, seconds, Celsius, and then you say that I'm not comfortable with SI units. I'm using like English units, right? And if you want to do the conversion, we use like conversion factor. which is basically a ratio right here, or fraction, that it has a desired unit over given unit. Or, depending on the problem, it can be like, for instance, if I tell you, 1 inch equals 2.54 centimeter, 1 inch over 2.54 centimeter is a conversion factor, or 2.54 centimeter over 1 inch is a conversion factor. So conversion factor basically is a way for you to convert units. And it should be, if you do the math, it should be 1. Because 1 inch equals 2.54 centimeter. Does that make sense? So in general, when you want to solve the problems, you are given some information. You multiply that by the conversion factor or conversion factors, and you get information that you're looking for. So in general, given unit multiplied by conversion factor gives you desired units. And make sure to write the conversion factor somehow, that when you have the given unit here, you have the given unit in the conversion factor on the denominator, so they cancel out, right? And as I mentioned, if you have like difficulties with like fractions, like decimal points, or like basic mathematical, or algebraic equations, and if you have like math difficulties, refer to the videos that I posted in the previous lectures, or just email me. I'll be glad to explain things for you. So just don't be ashamed or afraid to reach out to me. I try to be really accessible, and if some of you emailed me, and you see that I'm pretty quick to respond to your emails, and I don't want you to suffer in chemistry because you don't know math. Does that make sense? So just email me anytime that you have any difficulty with the course, no matter what that is. So, okay, so if I give you like 15.6 inch, and I ask you to convert that to centimeter, you write a conversion factor, and you write it somehow that inch and inch cancel out. So you write inch in denominator, and in your numerator you have like centimeter, because the answer should be in centimeter. So now let me ask you this. Can anyone tell me that when I do this mathematical operation, my answer should have how many significant digits in this question?
3.
So why 3, why 4? So what number should I look at?
The information given.
Why?
I guess that's what you're given.
Yes, that's what is given, and also this one is a measured quantity, right? Can anyone tell me, so this is a measured quantity. Is this number over here, is this a measured quantity?
Yeah.
So how many people say yes? How many people say no? So why it's not a measured quantity?
I don't know for sure, I'm guessing.
Oh, yeah, that's fine. I mean, no worries. I just want you to have like a conversation, and then we learn together. So don't be afraid to answer the question. So, any guess that why it's not a measured quantity? Yes?
2.54 is part of the conversion factor, so it wasn't measured, it's just given to us, right? So
Yes. Can anyone, so exactly what you said is right. But does anyone remember what did we call these types of numbers? Yes? Exact number, right? So defined quantities are like exact numbers. Can anyone remember how many significant digits exact numbers have? Unlimited, remember? So this number has like unlimited significant digits. And if you couldn't read my handwriting, just let me know. Just don't give up on learning because of me. Okay. And can anyone tell me, when we had like multiplication, what would we focus on? Anyone?
Significant numbers.
Exactly. Number of significant figures or significant digits. So we don't work with numbers after decimal place. In like multiplication, we work with significant digits. So how many significant digits this number has?
3.
And that number has like unlimited. Which one is lower? 3, right? So my answer should have 3 significant digits. Is that clear? So when you write the number, when you do the math in your calculator, the number that you get, you round it to have like 3 significant digits. Good? Any questions? Okay. Now, it's basically kind of like summary of what I just said, like more examples. So remember that these conversion factors, so if you want to convert like inch to centimeter, like kilogram to pound, those things I'll give you, don't worry about them. Unless I tell you kind of like, I expect you to know this. For instance, the prefix multipliers, like what is kilo, what is like mega, what is like nano, those things I expect you to know. But these things here, I don't expect you to know the numbers. I mean, it's good to know that if you have a ruler that has both inch or like centimeter, or like you go to a store, you want to buy a laptop or like a phone, and in centimeter and then they're listed in inch. It's good to have an idea. So I guess, I just encourage you to know that 2.54 centimeter is 1 inch. But for your exam, I don't expect you to know that. I'll give you this conversion factor. And when you want to write this, expression here as a conversion factor, you can write like 2.54 centimeter over inch, or like, I guess 1 inch over 2.54 centimeter. Both are conversion factors depending on what you want to find. And here I encourage you to, go through these examples yourself, solve them to make sure that you know how to convert, for instance, 44.7 centimeter, to inch, or vice versa. And the point here is that if you write the conversion factor like this, and remember, you treat the units as if you treat the numbers. So here, if you multiply these two numbers together, divide by 1, you multiply centimeter with centimeter and divide it by inch. So here, you didn't find your answer in inch, right? Because you had the conversion factor written, reverse. You should write it 1 inch over 2.54 centimeter. So as long as you write the units can guide you to the answer. And can anyone tell me what was the name of this that I just said? Using units as a guide to solve problems. Yes?
Dimensional analysis.
Exactly. So remember to do dimensional analysis to make sure that you find the answer correctly. Because in your exam, and also your quizzes, this is how I put myself in your shoe and then think what mistakes can you make, and then I put that in one of the answers in multiple choice questions. So make sure to have to do dimensional analysis to know that this answer is wrong, this answer is correct. Good? Okay. And we also can use, I encourage you to use solution map. And as we said, is a visual outline to solve a problem. And we can also diagram conversions using a solution map. And as we said, it shows you a strategic route required to solve a problem. And these things, I list here because I'm going to ask you in your homework problems, in your quizzes. So know that, okay, this is solution map, the visual outline of the solution to a problem. It's not like dimensional analysis is not significant figures, it's just like solution map. It's kind of like a map that shows you how to solve a problem, basically. And for unit conversion, the solution map forces on units and how to convert from one unit to another. What that means is that here, for instance, we have like a solution map. We have like inch, we want to convert it to centimeter, and then we have like this conversion factor that we write, in our solution map. And the reverse can be right too. You have centimeter, you want to convert it to inch, and then you write the corresponding conversion factor. And remember, if you are given centimeter in your conversion factor, write centimeter in denominator so these two can cancel out and you find the answer in inch. Does that make sense? Okay. And also, there's something on my, oops. If I can manage to get that back. Okay, good. There was something in the iPad was bothering me. Okay, so general problem solving strategy. So first, you see what information you are given, kind of like starting point. And then you find a way to solve the problem, right? I guess that one is like the third point. So first, you identify what information you are given, and then you identify what you want to find, basically endpoint. And you kind of like find a way or devise a way to get from a starting point to the end point, right? And in that procedure, you can use whether information that you are given or information that you already know. For instance, 1 inch equals 2.54 centimeter. That's something that you can look up. So you're welcome to use that information. So whether you have the information in the problem statement or you can, look that up. And basically you have the given information, you construct a solution map and find the answer. Any question? Most of the time in all your courses, you already do that, right? You have like some information given, you want to find something, and then you solve the problem with better information that are provided, or you can look up. Okay, and again, you sort the information, you strategize, a way to solve the problem. You solve the problem, and then you check the answer. And this is really important. Sometimes I tell you like how many, and I'm going to talk about atoms and molecules, so these examples make more sense. But I tell you how many oxygen molecules are in this room, and then you solve the problem, you find 2. And then we learn later on that atoms and molecules are so small, and there are like lots of them. It's kind of like to the order of 10 to the power of 23 or more of atoms. So if you solve a problem and then you find like 2, you know that you solved the problem wrong. Or if I tell you what is the mass of this book, and then you solve the problem, and then you tell me that is like 2 kilograms. Or like you tell me that is like minus 2 kilograms. And then I tell you, what does that mean? We don't have for our daily lives, mass is always positive. So minus 2 doesn't make sense. You know that you did something wrong in the problem. So throughout this course, any problem that I give you, check the answer. That is really important, and it prevents you from making mistakes and losing points. Does that make sense? Good? Okay, so now it can be, from the example that I gave you before, we had like inch, we wanted to convert that to, centimeter. It can be examples that both in your numerator and denominator, you have like different units. So if I tell you, a number for like gas mileage of a car, and then just before here, I just like, Googled some information about like different cars, and when I wanted to buy a car, I was just like considering different factors, and one factor was like gas mileage, and if you know the number in like miles per gallon, and then you want to convert it to kilometer per liter, right? So now we want to know how to do that. So the procedure is fairly similar, but now we have like 2 steps. And then to kind of like make this more, applied, I guess, in a sense, I was, looking at like Toyota Corolla, Ford Escape, Honda Accord as some examples. I'm just going to write one number. And then they have like different gas mileage, whether you're going in the city or like a highway. So imagine like, if I tell you 40, for instance, mile per gallon, and that is for like highway. So these are like just like details, you don't have to worry about them. But what I asked you is that, convert 40 miles per gallon to kilometer per liter, right? And just for the sake of having this example consistent with what I wrote here, I just write that 44. And that is, to be kind of like accurate, this 44 corresponds to, Ford Escape for like when it goes on city. Just like to don't give you like wrong information. Anyway, and I just Googled this number. So, and it was just the first thing that Google showed. I told you in this class to just don't say that I Googled this number. So if you want to, for your lab, to report something, just like have the URL of the link, But as I said, just like, I just want to solve a problem quickly. So just accept this, from me. Anyway, so what I recommend you to do, that you are given 44 miles per gallon, right? You want to convert that to kilometer per liter. Now you should write 2 conversion factors because you have like 2 different units that you need to convert. One of them is mile, and you should convert that to kilometer. The other is gallon, that you should convert that to liter. Are you with me so far? Is that clear? So now you write a conversion factor that if I want to first take care of miles, okay, in the conversion factor that I'm writing, converts miles to kilometers. So in this ratio, this conversion factor that I'm writing here, what should I write? What unit in denominator? Miles. Is that clear? Because I want miles cancel out, and I want to convert that to kilometer. Any question about that? So now, can anyone tell me what is the number here based on these units that I wrote here? So what is the numerator in this conversion factor? Anyone? 1.609, because that is like 1.609 kilometer, right? What is the denominator here? 1. Any question about this? You want to get rid of miles, so you should write it in denominator so it cancels out, right? And then you want to find kilometer, so you should write it in numerator so it stays. Good? So now I took care of kilometer, or like miles. And now I want to convert gallon. So in this conversion factor, just tell me, in the sake, if we're talking units, what units should I write in numerator? What is it? Meters. So I want to convert gallon to liter. So, and I want that to cancel out, So if I want to write in numerator, I should write gallon, so this gallon cancels out here, right? Are you with me? So what should I write in denominator? Liter, right? So what number should I write in numerator? 1, because I have 1 gallon, right? What number should I write in denominator? 3.785. Any questions about this? And I just put these numbers to, save some times in calculator before coming to the class, and that would be like, this is what calculator gives me. And as I said, always write the units. We don't write any numbers without a unit. Okay? So now, can anyone tell me, if I ask you this in the exam, what should you write if you want to use correct number of significant digits? What is the answer? Two. Yes, so what would be the answer? 19. Can anyone tell me why I didn't use like 4 significant digits? Isn't like 1.609 or like 3.785 have like 4 significant digits? So why did I wrote the answer with 2 significant digits? Yes?
Because it's the lowest number for the 44.
Exactly. So So that is the lowest number, but what can be other explanation? Yes?
1.609 and 3.785 are exact numbers, so they're limited.
Exactly. So they are exact numbers, right? They are defined quantities, so we don't even look at them when we solve the problem. We have just like one measured quantity. Does that make sense? Okay, any question about this? So this is kind of like all the problems that we solve in this course would be this format. We write a conversion factor and then we convert units from each other, to each other. And also there's another way to write this. You can write kind of like a, you can write your solution map as this, right? Like 45 miles per gallon, and then you write 1 mile here, 1.609 kilometer, and then cancel these 2, and then write 1 gallon, 3.785 liter, and then cancel these guys, and then write the answer, which would be like 1.609 over 3.785 multiplied by 44 kilometer per liter. So this is another way of writing the same information. So whichever is more convenient for you. I use this one myself, but I had several students last semester that they were like more comfortable to have their, conversion factors written as this format. So as long as you do the mathematical operation correct, that would be fine. Any questions? Okay. So now, what if we have like units raised to a power? As I said, treat your units as if they are like numbers. If you have like 2.54 centimeter and you're raising 2.54 to the power of 3, you should raise centimeter to the power of 3 as well. So by the same token that when we had like, numerator, denominator, anything that we were doing with the numbers, we would do with the units too, is the same. If you have like 1, centimeter, and then you're raising that to the power of 2, you should also raise like centimeter to the power of 2. So this would be 1 squared centimeter, right? Or the same with like inch, or like if you have like 2.54 centimeter equals 1 inch, and you want to, raise everything to the power of 3, not only you should raise this number to the power of 3, you should write and then raise this unit to the power of 3 as well, and 1 to the power of any number would be 1. Is that clear? Okay. And now we talked about density too in the last class. Can anyone tell me what was density? Anyone remembers? And you can look at the board too, I just want you to be present in the class, pay attention to what I'm saying, not in your, thoughts or like.
Ratio of mass to volume.
Exactly. If you have like, a compound or anything, if you, measure their mass and then their volume and divide the two, we have like the density of that compound or that object. And we denote density with D, mass with M, volume with V, basically the first letters of them. And most of the time I ask this, in the exams, what is density? Or like what does the following definition represents? Or which one of the following is not a unit of density? Remember, we talked about units like 3 class before, like what are the units of mass, what are the units of volume. So anything, if I tell you like kilogram per cubic meter, so is this a unit of density? How many say yes? How many say no? Why it's not? So how many say yes? How many say no? How many don't care? Okay, I want you all to participate, because as I said, the only way that you fail the course or like get bad grade is you literally don't care. As long as you care, I guarantee I make that happen, that you get a good grade. So with that being said, how many of you are saying that kilogram per cubic meter is a unit of density? How many say it's not? So why it's not a unit of density? Okay, so I wrote like a fraction, maybe I wrote it bad here, that it has like kilogram in numerator and like cubic meter in like denominator. So the density of a substance is the ratio of its mass to its volume, right? Basically mass over volume. Is this a unit of mass? Is this a unit of volume? So is this a unit of density? Right? Is that clear? Good? Oh, okay, yeah, sorry. Yeah. So, kilogram per cubic meter. Good? Okay. So now here you have like some common, density of substances, and the unit is like here, gram per cubic centimeter. And again, this can be a unit of density because gram is a unit of mass. Cubic centimeter is a unit of volume. So gram per cubic centimeter is a unit of density. But if I tell you gram per centimeter squared, this is not a unit of density, or like gram per centimeter. That is not a unit of density. And this table gives you an idea of like, the numbers. And then density of water is like 1 gram per cubic centimeter. And I don't expect you to know these numbers. I just know the density of water myself. And like ice is a little, smaller. So it's good for you to know, at least for water. But the rest, don't worry about it. Just know the things that I just mentioned before. Any questions so far? Okay, so that is like the conclusion of our chapter 2. So before I start chapter 3, does any of you have any questions? Good? Okay. So now we want to talk about matter and energy. Then first we start with matter. So virtually everything is made of matter. So everything that you can see in this classroom is made of matter. And also there are things that you cannot see in this classroom, but they are again made of matter. Can anyone, or they are matter rather. Can anyone give me an example of something that you cannot see but is a matter?
Air.
Air, exactly, excellent, yes. What is it? Yeah, so sometimes, you have like humidity in the room. It's like water, right? But you cannot see it. Sometimes you can, but sometimes you cannot. And that is like matter too. Or like you have like carbon dioxide. You can smell it, and you're suffocating because of the bad smell. Or like carbon monoxide can kill people, And you hear in news that sometimes there was an accident in a home, and people suffocated because of carbon monoxide. They cannot see it. That's why, people, sometimes if you are in the room with a certain smell, at some point, you cannot smell it. You just get used to it. So because we cannot see them, they can be even more dangerous, right? So your book like gives examples of, and then draws these nice molecules that everything is just kind of like composed of matter. So these are the things that I'm going to ask in your homework problems and then quizzes, exams, and so forth. And I want you to know the definitions well. So we define matter as anything that occupies a space and has mass. You may argue that does air has mass? The answer is yes, it does. But we're going to talk about gases in the next slides. But gases take the shape of the container that they are in. So in this room, if we just close the doors, we have like, oxygen gas in the room, and it takes the space of this room. But we can compress the gas, the oxygen in this room, and then just make it, to a cylinder or like bottle, depending on how much we can compress it. So, and then when we do that, we can just measure the mass of them. So yes, they have mass. So matter is anything that occupies space and has mass. And as we mentioned, some types of matter are visible to our eyes, like steel, water, wood, plastic, And some types of matter are not visible to our naked eyes, such as air, microscopic dust, right? Sometimes you can see the dust, sometimes they are like microscopic and you cannot see them. And your book says naked eyes because if you have like a microscope, you can see, depending on the precision of the microscope that you have, you can see these other types of matter as well, but you cannot see them with just your eyes. Does that make sense? Any questions so far? And even if I don't say any questions, anytime that you have any questions, just raise your hand, So don't have any questions unanswered. Now we want to talk about elements. And as I mentioned, in the first slide, so anything that I'm talking about is like just from your book. So that's why from previously I was just like referencing through a book, but then I realized I'm just teaching off of it. So I tell you that everything is from this book. But if I use something or write something that I didn't explicitly wrote from your book, I reference it here so you can just like refer to it and then read more if you like to. Or like sometimes I have like pictures, that I just don't want to plagiarize, so I reference them. You don't have to go look at the pictures. You're welcome to, but the thing that I'm saying most applies to, these links here. So all matter are composed of substances that we call elements. And elements have specific chemical and physical properties and cannot be broken down into other substances through ordinary chemical reactions. For instance, if I have iron, right? Have any of you ever had like a piece of metal, like iron, like whether it's a spoon that was like made of iron, or like a pot or pan, or like anything. And then after, you put it in humidity, you saw something like, you saw rust on it. Any of you had experienced that, right? So that involves, you have like, that specific object that you have is made of iron, right? And then when it's exposed to oxygen, it goes through some chemical reactions, and then you see iron oxide. That's the, rust, kind of like the orange, kind of like, what color you call it, like brownish color that you see is like iron oxide. But still is the same element that combined with oxygen, like, right? So iron didn't convert to gold, right? And you heard like, from like, Greek philosophers or like ancient chemists, they were trying to do alchemy, they were trying to convert, copper to gold, So in a special circumstance, so that's why your book says like ordinary chemical reaction. With the ordinary chemical reactions, we cannot convert copper to gold. So this is like the definition of element, that, all matter, is made of substances called elements which have a specific chemical and physical properties and cannot be broken down into other substances through ordinary chemical reactions. Is this clear? So what is an element? Right? And we're going to have like so many definitions, so make sure that you know which is which. So this is element. So all matter, is made of substances called elements. Gold, for instance, is an element, and so is carbon. There are 118 elements, but only 92 occur naturally. The remaining elements have only been made in laboratories and are unstable. And as we go through the, CHEM101 course, I tell you, and I tell you right now too, that we put all the elements in a table here that we call periodic table of elements. And if you see over there, I cannot reach it quite well, but OG, it has like the atomic number of 118, and you don't have to worry about these expressions I'm going to explain to you. Just worry about the things that I write here. But you see the number 118, we have like 118 element, and we write them like 1, 2, 3, 4, 5, 6, and then we reach here. But 92 of them occur naturally, that they are around us and then you can find them in nature. The other ones, scientists made synthetically in laboratories. And even some of the elements, are not discovered yet. Few of them. You can go, Google about this and then find out all sorts of information. And we're going to talk about them later on in this course. But as of right now, you know that we have like 118 elements and 92 of them occur naturally. And what is the definition of element? Are we good? Are you still with me? Okay. So now that we learned about matter and element, we want to learn about atom. And we mentioned atoms when we started this course, and we said all matter compose atoms, right? So matter basically is ultimately composed of atoms, submicroscopic particles that are the fundamental building blocks of matter. So all the objects that you have, everything that you can see, all matter, they are composed of atoms. Any questions? An atom is the smallest identifiable unit of an element. So all these elements, they are made up of atoms. And they are like smallest identifiable unit of an element. Any questions about any of these definitions? So we have matter, we have like element, we have like atoms. All matter, composed of atoms, and all elements are also composed of atoms. Good? Any questions? Okay. So now these atoms that we just mentioned, they can, bond together, and we're going to talk about chemical bonding as we progress with the course. But in general, two or more atoms can bond together, meaning that they can join together and they can, form chemical bonds, and these atoms can form molecules. So this is the definition of molecule: two or more atoms joined in a specific arrangement by chemical bonds. In many cases, atoms are bonded together to form molecules. Two or more atoms join to one another in a specific geometric arrangements. So in general, in many compounds, two or more atoms, they bond together, they join together to form a molecule, and it can be like different types of arrangement. And basically our course is about like atoms and molecules, and we're going to discuss these things in more details in the next chapters. But as of right now, just know that all matter, they compose of atoms, and these atoms can just join together in different geometric arrangements and like in different ways to form molecules. Any questions so far? Everything's good? Okay. So now, there are different ways to classify matter, right? Kind of like if I want to, classify students in this class, I can classify them like based on their grades, right? I can classify them based on, different ways, I don't want to say anything that would be problematic or like I talk, politically incorrect. So I can just like classify students in different ways. So it's the same thing based on like the matter. We can classify matter based on different factors. One way is based on state. And the state meaning that, whether it's like, the matter that we have, is it like liquid? Is it gas? Is it like solid? Exactly. So now in here we have like water, right? So can anyone tell me what is the state of water? Exactly. What is like steam?
Gas.
What is ice?
Solid.
Exactly. So because I want to first go through the attendance and we have like more questions on that, let me first do the attendance, and if I get like more time, I continue with the lecture. Otherwise, I just do that next session. So in your attendance today, the person in charge of SI Pass, Samantha, sent me some questions and asked me to incorporate them in my attendance. So I encourage you and I asked you to also answer those, because we want SI Pass to be as effective as possible for all of you. And then if the time doesn't work, if you don't find it useful, we want to improve the course and also SI Pass. So answer those questions as best as you can, so we can like be more efficient. And let me know if you have like problem with the link, as always. Can anyone see the link well? Just do this. Now the picture that I chose, kind of like lost the pixels. Yes.
For some reason, the links still aren't working for me. Every time I've tried to do it, it just doesn't.
Do you type it in the top drawer or so? Anyone else? help.